Today we are looking at the continuation of polynomials. We have already discussed the addition, subtraction, multiplication, and division of polynomials. We are now moving on to the next level of remainders theorem. In this area, the reason for that is because we are interested only in the remainder when a polynomial is divided by a divisor. We may not need to go through the long process of division. We can easily get the value, which is the remainder, if it is divided. And that is why we talk about the remainders theorem. Remainder theorem. The theorem states that if a polynomial f of s is divided by s plus a, the remainder is f of minus a. Similarly, if it is divided by s minus a, the remainder is f of a. If it is divided by 2s minus 1, the remainder is f of 1 over 2, which is half. This is the principle we are going to employ or apply in solving problems on remainder theorem. So if you are asked for the remainder, you simply apply this rule, as we are going to see in the examples below. Example number 1. Find the remainder when 3s cubed plus 5s squared minus 11s plus 4 is divided by s plus 3. Solution. First of all, put s plus 3 equal to 0. Therefore, your s is equal to minus 3. Then substitute this value. Substitute s equal to minus 3 in the expression. In other words, if we have p of s to be equal to 3s cubed plus 5s squared minus 11s plus 4, then we cannot put our s as minus 3, and this becomes 3 into minus 3 cubed plus 5 into minus 3 squared, and then minus 11 into minus 3, and then plus 4. You will now simplify this, and this will give you minus 27 times 3. So we have 3 times minus 27, and then of course plus 5 times 9, and then this is plus 33, and this is plus 4. You can simplify further. 3 will multiply this, that is 21, 6, 7, 81, and then plus 45, and then plus 37. So you add this to give us the solution. What will be your answer? The final answer will be equal to 1 if you simplify this. So this is the remainder. So the remainder is equal to 1. Example number 2. Find the value of k if the expression ks cubed plus s squared minus 5s minus 2 leaves a remainder 2 when it is divided by 2s plus 1. Solution. Now here, once again, we put our 2s plus 1 to be equal to 0, giving you s equal to minus half. Alright. Now, it means that if we substitute s equal to minus half in the given expression, we will now have a remainder which is equal to 2. So, we have k into minus half all cubed plus minus half all squared minus 5 into minus half and then minus 2. The answer is equal to 2, which is the remainder. Applying the remainder theorem. Now this becomes minus 1 over 8k, and this is plus 1 all over 4, and this is plus 5 all over 2, and then of course this is equal to 2 plus 2, and that is equal to 4. By moving minus 2 to the right hand side, it becomes plus 2. Now let's simplify this. Remember that this is equal to 4. When we simplify this, we will have to find the value of k. So let's multiply all through by 8 to clear the fraction. So we have minus k. If you multiply this by 8, you have 2. If you multiply this by 8, you have 20. Multiply this by 8, you have 32. Makes it easier. So in this sense, we now have our k. So we have here 22 minus 32 is equal to k. If I move k to the right hand side, it becomes plus k. And I bring my 32 to this side, it becomes minus 32. So if you subtract this from that, we now therefore have k to be equal to minus 10. And that is the solution to the problem. Number 3, find the values of p and q such that s minus 1 and s minus 3 are factors of ps cubed plus qs squared plus 11s minus 6. Solution. By the use of the word factors of, it means that they can divide this without a remainder. In other words, the remainder is equal to 0 when s minus 1 and s minus 3 divide this expression. So the first thing is, number 1, put your s minus 1 equal to 0, therefore s is equal to 1. So putting your s equal to 1 in the expression, so we now have p into 1 cube plus q into 1 squared plus 11 into 1 minus 6, and the result will be equal to 0. Now when you solve this, you have p here, you have q here, you have 11 minus 6 is 5, so that will be equal to minus 5. Call this one your first equation. Then the second equation will be, put also your s minus 3 equal to 0, therefore your s is equal to 3. And again you now have p into 3 raised to power 3 plus q into 3 squared plus 11 times 3 minus 6 is equal to 0. Now let's simplify this to give us 27p, and this will give us 9q, and this will give us 33. And of course 33 minus 6, what would that be? That would be 27. Everything is equal to 0. To simplify this further, we can reduce them to their lowest term by dividing all through by 9. And that will give us 3p, and then this is plus q, and then this is 3, and becomes minus 3. And this is our second equation. So bring in the first equation here, and that first equation is, let's take it from here. Bring this one down here. Okay. So this means p plus q equal to minus 5. What is the result of this? We can subtract, because the coefficient of q here and q here, they are the same. So if you subtract this, you have 2p is equal to minus 3 minus 5 will give you 2. Therefore your p is equal to 1. You can now substitute to get the value of q. So in the first equation, you can have our q will be equal to minus 5 minus p, which is minus 1. And the answer here is equal to minus 6. So our answers are p is 1 and q is minus 6. P is 1 and q is minus 6. Gives you the solution to the problem.